Today we are going to see the topic equilibrium. These are the contents present in our topic equilibrium. Introduction, equilibrium, physical equilibrium, chemical equilibrium, homogeneous equilibrium, heterogeneous equilibrium, law of mass action, equilibrium constant, application of equilibrium constant, conclusion, and last one is the reference. You can see one by one. At first is introduction. In our daily life, we observe several physical and chemical changes. Have you ever wondered what happened due to this physical and chemical changes? For example, a banana gets ripened after a few days, silver gets tarnished in few months, and iron gets rusted slowly. These processes proceed in one direction. The reaction which takes place in both the forward and backward direction are called reversible reaction. Next, we are going to see about equilibrium. There are different types of equilibrium. For example, if two persons of the same weight sit on the opposite sides of a seesaw at an equal distance from the fulcrum, then the seesaw will be stationary and straight, and it is said to be equilibrium. These are one of the examples for the equilibrium. State of equilibrium. A system is said to be in the state of equilibrium if the properties like concentration, temperature, pressure does not change with the time, then that is said to be state of equilibrium. Physical equilibrium. A system in which the amount of matter constituting different phases does not change with the time is said to be in physical equilibrium. We can call the system as in physical equilibrium when the amount of matter at different phases does not change with the time is said to be physical equilibrium. Next is solid-liquid equilibrium. If some ice cubes and water are placed in a thermoflask at 273 Kelvin temperature and 1 atmospheric pressure, then there will be no change in the mass of ice and water. The rate of melting point of ice is equal to the rate of freezing point of water. H2O is in solid is reversible to H2O in liquid. Then we are going to see about liquid-vapor equilibrium. The temperature at which the liquid and vapor phase of a substance of a equilibrium is called boiling point and condensation point of that substance. Rate of evaporation is equal to rate of condensation. H2O in liquid is reversible to H2O in gaseous phase. Next is dynamic equilibrium. A chemical equilibrium is said to be dynamic when both the forward and reverse directions takes place on equal rate. Once the equilibrium is attained, the properties such as concentration, temperature, reactant, product, pressure, etc. remains constant and does not change with the time. Next is chemical equilibrium. At this state, the rate of forward reaction become equal to the rate of backward reaction. So chemical equilibrium is a state of dynamic equilibrium. For example, H2O that is in gaseous phase and I2 is also in gaseous phase, reversible gives 2HI. Types of chemical equilibrium: homogeneous equilibrium, heterogeneous equilibrium. Homogeneous equilibrium. If the reactant and the product are in same physical state, then it is called homogeneous equilibrium. Example, N2 plus 3H2 reversible gives 2NH3. If the reactant and product are in same physical state, then it is called homogeneous equilibrium. Heterogeneous equilibrium. If the reactant and the product are in different physical state, is called heterogeneous equilibrium. For example, calcium carbonate CaCO3 reversibles gives carbon dioxide that is CO2 and CaO lime. Law of mass action. The rate of chemical reaction at a given temperature is directly proportional to the product of active mass of the reactant. At that instant, rate is proportional to reactant power x. Equilibrium constant. For a chemical reaction, the equilibrium constant can be defined as the ratio between the amount of reactant and the amount of product which is used to determine chemical behavior. At equilibrium, rate of forward reaction is equal to the rate of backward reaction. Next is application of equilibrium constant. The knowledge of equilibrium constant helps us to predict the direction in which the net reaction will take place, predict the extent of the reaction, and calculate the equilibrium concentration of the reactant and product. Conclusion. Therefore, in our daily life, we observe several chemical and physical changes. There are different types of equilibrium: physical equilibrium and chemical equilibrium. A system in which the amount of matter constituting different phases does not change with the time is said to be physical equilibrium. At this state, the rate of forward reaction becomes equal to the rate of backward reaction. So chemical equilibrium is in the state of dynamic equilibrium. Reference. These are some of the reference for the topic of equilibrium. Thank you.